Thank you for joining me today at the Airflow Summit. I'm really excited to be here to talk about something I'm passionate about: understanding what happens deep inside the tools that we use every day, one of them being Airflow. Today, we are going on a journey titled Airflow 3 and Open Heart Surgery. Not that I'm a doctor or I know much about Airflow, but later on in the slides, we will figure out together what was the inspiration behind the title for this talk. We are going to peel back the layers of one of the Airflow's most common operators and see what's really going on under the hood. So, I want to start with a question. How many of you have run once Airflow in your life? Almost everybody. And how many of you are familiar with Bash operator? Very good. Sets up very well for the next few minutes. Okay. Generally, what we will do next is we will find out what is this small Bash operator, which we use every day, what actually happens under the hood when this operator runs, all the modules it calls, and we will see that in action. This talk is about answering the question that we will visualize all the inner workings of Airflow, reveal the code blocks and modules called when the operations are running. How do we explore Airflow inner workings? There could be few options, right? You could read documentation, which is quite good, I would say. You could also browse the source code on GitHub, but browsing the code could be navigating a massive, complex city without a map. Instead, we will follow a slightly different path, which is actually very common, but we don't follow this path to learn things. We will start by installing Airflow locally, run the Airflow standalone command, and then we take the things from there. So our journey begins not by reading docs, but by exploring and running tasks. So once we run the Airflow standalone command, the first thing you will see, many of you are familiar with this logs, is the raw logs from Airflow. First thing we will do to explore this journey of learning is to see the components here. So you can see API server, triggerer, DAG processor, and its scheduler, I think, right? So these are the 4 components that we have got without thinking, learning, reading. It's just right in front of us. Now, what can we do with these components, right? We want to go deep into them. What's the way we can achieve that? So one option that Airflow 3 now has, it has the OpenTelemetry native support, meaning Airflow core components are passing on traces for us to analyze them. So how could we achieve that? First thing is we set up the OTel collector using a normal binary with some configurations passed in. Next thing is we will enable these OTel traces in Airflow. So you just open up the Airflow CFG file, make few of these changes. And the nice thing about this is that these traces start going into whichever telemetry provider you want to use. In our case, we want to keep it simple for now. We will just use Jaeger for this to visualize things. And by running this Docker command, next thing we know is we have a local environment running. Now we can see Airflow core functions in real time. And actually, these are the core functions, not something that you run. You will see that in a while. So I have a picture of Jaeger, but let me skip the traditional way of recordings and whatnot. Let me take a gamble to do a real demo. Let's see how we go there. And actually, this resonates with exploration as well, right? Whenever you want to explore something, it's pretty unplanned. Things can go accordingly or cannot go as well. So let's go to the browser, the IDE. I tend to use PyCharm today. The VS Code guys, please don't hate me for that. So I have the OTel collector running here. the Jaeger command that you saw, there is a Docker container up and running there. Next thing we want to do is we want to run Airflow. So the Airflow is running. What we are expecting now, one thing I forgot is the hotel service is called Airflow here. So if you will go to Jaeger, you have to find for this service name. So we see a service name Airflow. We could search for this guy. And actually, my time zone is slightly different, but you can see these are the real traces as we speak. Okay, so what do we see here? Part one is we see different operations. These are the operations that Airflow does for us behind scenes. And the power behind them, generally, we don't really know what's happening in them, but we can see from their names and try to explore what things might mean. For example, if I scroll towards the bottom, I see something called scheduler job loop. I see it here as well. If I click on it and I click here, I can see the inner workings of this thing. I hope it is readable. If not, I can make it a bit bigger. So you can see here, once the operation of scheduler job loop runs, it has create dag run as a module, then start queue dag runs, heartbeat, trigger tasks, and whatnot. These are actually findable traces that you can go in the Airflow code and learn more about them very easily. Then let's go slightly back and find out some functions like heartbeat and try to find the traces. Did you see one thing? That this thing seems to be running much more frequent than anything else. And there is also one thing, this thing seems to be running in multiple different spans or operations, whatever you want to call them, right? So this thing runs standalone and this thing runs within other operations as well. This makes me wonder, maybe this is amongst the core components, this is even something more important, right? So by looking at the frequency and such things, we can also start making more sense what is even more critical for Airflow, and whatever is critical for Airflow, at some point it will become critical for us if it starts going sideways. Okay, let's go back to the presentation. We don't need you. So far the demo is working good. Okay, next thing we did was in the dropdown, we saw quite few operations. The only thing we did was we just copied them from Jaeger into this slide just to think about them. Now, as a new person who doesn't know much about Airflow, I would like to categorize them to make some sense out of it, right? So what can I see? I see schedule, scheduler, scheduler, scheduler. So these tend to be belonging to some component which could be called scheduler, right? And that component we saw at the start of the logging as well. So let me do that. So now they belong to scheduler. One thing really nice about these spans when I was looking at them, look at this thing called current scheduler exited. Actually now in traces of Airflow 3, you can actually see when your current scheduler got shut down by some reason or you shut it down yourself. And look at this beautiful thing, new scheduler. So you can actually see when the new scheduler comes up. These are few very handy things. We continue our journey with intuition. There is no documentation we have read, right? Metrics tend to go in monitoring, right? And then so on and so forth. Next thing. Now, based on all of this basic information, we have made a hypothesis or whatever we want to call that. We have now 4 main categories in which we can divide these traces coming in. One is scheduler, triggerer, monitor, and DAG runs. Let's keep these things in our mind to start going more deeper and deeper, because no one else will help us except we ourselves, right? We're not going to go to any documentation or anything. So as an Airflow user, what do we do next? Airflow is running. We would like to run a task, right? And since all of you are familiar with the bash operator, I think I picked the right choice for moving forward. So this looks pretty common code. Don't judge me for the quality of this one. It's just for demo purposes. So within these few lines of code, what do we expect that would be happening? So when the call.execute function gets called, what's our assumption? My assumption was the execute function would be triggered. There would be a sub-process library being called, which will run it. There will be an echo on my screen. and I would be done with the process. Sounds very straightforward, but is it really the case? Let's try to see together. When we started going deep into this thing, and you will do it in a while as well, we found out there were at least 150 plus functions invoked just to get this thing over the line. There were more than 15 modules being imported, more than 40 unique functions were called, and 5 major components were involved to get just a simple echo command over the line. Now, we should be asking the Airflow community as well, why is it so hard to run an echo command only? It's for the community to figure out. Let's watch this thing happen in real time as well. So let's go back. So the Airflow 3 for us is running. Next thing that we did was we created a small bash DAG for that. This DAG has 2 additional things. One is it is using the sys method, which has sys.trace, which allows us to see all the functions that run whenever any Python command runs. And the second part is we will be integrating OpenTelemetry with it, so these traces can actually go to Jaeger as well. So the next thing we do is we run this operator. Something nice is happening, and it shows us towards the end that we can see the traces in Jaeger as well. One thing you see here, we have set the name of the service to Airflow 3 demo. So before the service was Airflow, now it's Airflow 3 demo. It's very powerful in a way where you can ship your traces separate from Airflow core and make the correlation separately or however you like. Let's go to Jaeger for a sec. And as you know, in the dropdown, we no longer need to go to Airflow, but rather Airflow 3 demo. Let's try to find something in the last hour. And as you see, it's real demo. Time is real. We saw this thing, bash operator we ran, and whoa, 401 spans that we got here. Now let's try to explore them, what's happening in all of them. You remember the keynote from Kexil and Amok? They were mentioning everything should happen via the SDK thingy, right? So this makes me happy, like we are on the right path, right? So Airflow SDK basis, the operator, we imported the bash operator. Let's keep reading this thing. Something with SDK about execution time, then the logs, sounds good to me. Pendulum for sure, something with dates Airflow has to do. Keep going further, something more with logging. Let's try to find out where the heck is this bash operator that we tried to import, right? Right in front here. So now this is the .execute that we were thinking it should execute, but look what happened before that and what is happening after that as well. It's actually crazy. And look at the Airflow policies and things like this, but this story keeps going on more and more and more. For us to make, for the time's sake here, to make it faster, that's the reason why this code was written. It makes a little bit of a summary for us. Let's look at this summary. So here you can see all the modules. Let's make it a little bit up. Yeah. So this shows us all the modules that were imported during the run of this task. And you can see what were the active modules, what were the functions being called. One nice thing about this program, and all of this you can find on GitHub towards the end, I'll share that with you, is once the module is called, what is the function that is called from that module? This actually is super helpful in a sea full of moving things. You are now getting more focused on what components Airflow is using, and if you are interested in them, you can study more about them. Okay, till here looks good to me. Demo is done. So far, so good. So now let's, this was code. Now let's try to make a bit of sense out of it. What happened was some of the import modules happened, DAG would have been created, context building happened, sub-process management, logging and whatnot. If we put it in a very small summaries, like the key modules being imported were SDK, basis operator, we got the bash operator that we wanted to have, then something around context also happened, and then of course the sub-process has to happen, and then towards the end logging happened. Now with this, it makes me wonder that all of those modules being called were kind of justified. I mean, the Airflow community is not on a very bad track in that regard. And it makes me think as well, bash operator for us in Airflow, it's just not a sub-process.run, but it is much more. What more it gives, I think it gives us process isolation, timeout handling, signal management, retry logic, environment variables, and whatnot. You guys are much more familiar of this thing than I am. So it's not a simple bash operator, but for me, it seems like a production grade execution environment. And for this, I would like to take a moment to actually thank the whole Airflow community, where we run this operator maybe how many times every day, we don't know, as a community overall, but we don't really thank the people who have built this thing or they are maintaining it for us. So big shout out to everyone who's giving us this production grade execution environment. I want to just take a brief moment on highlighting the importance of OpenTelemetry native in Airflow 3, because it actually opens up a very big, horizon for us, because you could debug failures much faster, find bottlenecks, you can monitor patterns, you can deeply go inside and make the visibility of your pipelines. And you can also get some very good performance metrics, right? You were seeing if there is one specific core process from Airflow running later, you could do something about it in production as well. So seems like no more blind debugging. The power is with us. It's up to us how we want to use. Another discovery we found out, while you remember we saw this execution timeline, there were some processes which wanted to run like every second. One of them was heartbeat, metrics, something with events as well, and clean unused we saw running as well. So you remember initially I told you there was a motivation behind the title for the talk. So you see here there is something called heartbeat, and then there is called air, and then flow. Does it make sense? Like, yeah, forget about it. Yeah, so that's the reason why I came up with this name. But yeah, so this overall thing actually ensures for us reliability and observability all the time. Keep going further. What do we see in the current architecture? One thing we know is from Airflow 2 to Airflow 3, the way how we import things keep on changing. And if we are old enough, a few of us here, like from Airflow 1 to Airflow 2, we went through this process already, and now we want to go through one more time, but that's the nature of the thing. But in the next few minutes, we want to figure out together, is these the only changes that we got, that we just have to change few lines of importing libraries, or there are some fundamental changes happening in the architecture between Airflow 2 and 3? So from the keynote, we have heard that there are a lot of things, but we want to see them in action. Okay, then next few minutes we're going to spend on the inner workings comparison between Airflow 2 and 3. But before that, let's do a brief, recall of where we are. So we have now 3 very good sources of information. Part 1 are the raw logs from Airflow. Part 2 is the OpenTelemetry traces that Airflow 3 natively sends to us. We just have to enable them. And the third is these custom task level tracking that we have built. Now we have these sources of information available. The question is for us, how we would like to analyze them to make a difference between 2 and 3. Before we could go further, we have a bad news. OpenTelemetry is not supported in Airflow 2 as a native way. So the tracking that we were seeing in Jaeger coming from the Airflow core might not be possible for us to do an apple-to-apple comparison. But these 2 things we still have. So what do we do next? The same thing we did for Airflow 3. We have a same framework. We don't do fancy things. We run 2 commands, just change the port so 2 Airflows can be running at the same time if needed. And then the same principle gets followed. We get a screen. Let's zoom into this guy. You see this is the Airflow 2 local, and we start digging deep into what we see in front of our eyes. Triggerer, scheduler, web server, 3 components that we found. On the right-hand side, this is the same thing that we saw before. It's the Airflow 3. We can visibly see there is something extra / different. Pretty good. So what should we do next? We should do the component comparison. In the component comparison, what we find out that Airflow 2 doesn't have anything called API server, doesn't have any OpenTelemetry support, and Airflow 3 doesn't have anything called web server. We were familiar with this thing forever. And it has an API server, has native support with OpenTelemetry. Okay. So with just little bit of observation, we have found out few of the main architectural differences. And it didn't take us to any big documentation or any kind of a special talk or anything. It's you on a screen doing your things. Next thing, we want to do the same thing we did with Airflow 3. We want to do a task level debugging of what happens when a task actually runs in Airflow 2. So this on the right, you have seen, right? This SDK, whatnot, this statistics we saw. Airflow 2, let me zoom in. These numbers look very different, and this thing looks very, very long as well. But we don't like to see it like this. Let's do a demo. So let's just do one thing. On the left-hand side, this is Airflow 2 environment. And I just ran a simple process of bash operator that I had with Airflow 3. And on the right-hand side, you have a bash operator with Airflow 3 running. One difference in this script is this script does not send data to Jaeger or OpenTelemetry. Why? Because Airflow 2 doesn't have the native support, so there is not much sense to send this information there. Let's run this guy here as well. Here, this thing you have seen already. Let's go to the modules. Here we go. Okay. So do you see a very, very strong difference on the right and the left? Left being Airflow 2. I might have thought Airflow 3 would be running more modules because it's more modular, more fancy and whatnot. But actually it tends to give us something. Airflow 3 is more focused, more dedicated than Airflow 2. Airflow 2 might feel a little bit more of a monolith now compared to what I'm seeing here. 44 modules being called just to run a bash command. Sounds very, very interesting. And at the same time, what the heck are these decorators doing for me when I'm not using them? So, and if you look at the logs utilities, they look pretty much similar. So much not have changed there. There is this Python virtual environment in decorators as well. So if you look at the summary on the left and the right, you see 44 modules being called in Airflow 2, which is far more than in Airflow 3. Okay, now let's go back. So this is how this whole thing was created. You can also replicate this thing with the code I will share with you. Now we want to do the final part which is left, the core components deep dive. But OpenTelemetry is no longer supported, so we need to come up with a new solution. For that, we came up with a library called PySpy, not developed by me for sure. It's a sampling profiler for Python programs. It lets you visualize what a program is spending time on without restarting or modifying code. This sounds very good to me. Why? Because I can't really change the core myself, right? The thing I can do is if my core is running, how can I monitor it better? So this was very good for us. So what you do is very simple command. You could record a PID. So you see on which ID your scheduler is running, and you can just record and it will give you a flame graph. Let's try to see and generate few of these flame graphs. First thing we want to check is if there is an Airflow up and running already or not. And luckily, we have been running Airflow 3 together. We haven't shut it down, so no need to run it again. Now you can see here we have all the PIDs. So if I highlight this line for a second, this tells me 63087 is the PID for me, and it is running Airflow scheduler for me. Next thing I want to do is I have a profiling script, which actually just makes this little bit fancy, gets all the IDs of Airflow processes, so you don't have to do them manually. I can set in the duration for this thing as well. Let's run this guy. So what you are seeing here in front of your eyes is we are profiling scheduler with the PID we just saw, and then DAG processor, triggerer, and standalone things. We have given this 60 seconds to run. Maybe for the talk side, it was not a good idea. But yeah, in the meanwhile, let's do something else. These will be generated in 60 seconds as we saw. In the meanwhile, we can compare the previously generated flame graphs. Why not, right? So let's zoom in on this thing a bit. So on the left side, the formula is the same. You see Airflow 2. On the right-hand side, you start seeing Airflow 3. How do you know this thing if I'm saying the truth or not? You can see here it's called Airflow 2 local, which you have been seeing it's consistent. And here the directory is different. Now let's try to be humans and see. Humans are very good in finding differences, right? So these are all the 60-second profiles that got created for us, right? So you can see the first one is for DAG processor. The next one is for triggerer. The other one is for scheduler, and so on and so forth. But we're doing the same thing anyways in parallel. Okay, so let's try to find out similarities and differences here. Part one is we see almost similar. Second thing is we see this main.py is the same, but look, the line number is different. So has Airflow reduced 3 lines of code? I don't know. You can see the similar thing here. Scheduler is the function name. That's the file name. And that's the line number where the code is. So it's 58 and here it's 52. So on and so forth keeps happening. But one thing we see, underscore create DAG runs for DAGs is not found in Airflow 3. That's interesting. But don't worry about this thing. Generally, these are traces that we took for some specific amount of time. So one thing I myself do not know as of now, is this function existing in Airflow 3 or not? But if we were to find it out, it's actually not difficult for us. Why? We could copy the name of this function, go to our local environment where we have synced in Airflow, right? And then we could search for this name there. But anyways, so one thing is a surprise for me that in terms of how you are calling Airflow, Airflow 2 and Airflow 3 actually is not different. So how the core components are being called is in front of your eyes. They are exactly the same. I was thinking huge differences. This actually gives us one clue why this was the case. We can think about it. Did anyone say they modified something with CLI from the community? No one, right? So it's the same. You go to Airflow, say Airflow web server, it gives me the web server. So this actually makes much sense. Let's try to go a little bit further. A more simpler way for this, if you think I'm just trying to be fancy, it's not my job here to be, we can dump this thing in a text file as well, right? And that's exactly what I have done. So the same thing that you saw there, a little bit less fancier and a little bit less depth, I would say as well. So you can see the same things, just the line number here and the line number here are different. Now, this is a lot of information that you saw here. Is it very easily possible for me to figure out what are the differences here? Or did I dare not to say AI in my presentation talk? Because these days it can't finish without that, right? So let me be amongst everyone and I say, I would like to use AI to help me figure out the differences between the cores of Airflow 2 and 3. And what do we do next? We have a very good, rich data from 3 sources. What are those 3 sources? Part 1 was the task execution traces that we generated ourselves. We always get the Airflow raw component logs. We have different levels of logging, info, debug, warning, whatnot. So we can figure that out based on our needs. And we have these spy dumps and flame graphs, which in my opinion holds incredible amount of information. So what's the idea? Should we put all of this information to a LLM and figure out what it can do? Because I'm no good data scientist or anything, but what I have been told is if you feed in some good information to the models, they can give you some good answers. And one thing I'm very certain about, you cannot have much better tracing and code functionality than what you are seeing here. So the benefit of whole of this exercise is now we have very clear and verifiable areas to focus our learning and exploration. Why this thing is different than going to an LLM saying, please search the Airflow repo and give me the differences. Because this is not for you. This is for the full Airflow. If you were to see how much percentage of Airflow core you are using every day, all of us would be shocked because the whole base is too big and we are just using a small chunk of it. Now, what I try to do was I say, and I will not do a demo for this, just not to show which LLM I want to use just for the publicity or whatever. So what I did was I said, what are the architecture differences between Airflow 2 and 3 based on the data we have provided? All the data we have created right in front of you, right? Can you create some diagrams for us? What did we get back? For sure, LLMs will always give you an answer. Let's check it out. So this is a .md file which got created for us. Let's zoom into this a bit. So it starts telling me some nice things. It tells me 293 has a legacy monolithic architecture. I don't know if I fully agree with him or not, but he's right in some regards, right? He's saying you have a web server, you have a scheduler, you have an executor, you have a task execution layer. Look, what you see here, it's fully tailored on what we are running. It's not like some generic thing, right? Okay, let's keep going further. So he says the same thing. There are 44 Airflow modules. It's slightly tightly coupled, whatnot. Airflow 3, it shows a modern UI. I don't know if this thing should be here. We should not be seeing a web server in Airflow 3. That's what I was learning so far now. But LLMs now have this static, we can make mistakes, please read. So we keep going further. Here, another thing shows us the SDK, how this thing was being called. One thing nice I want to share with you is this. Look, it is showing us the directory level difference between 2 and 3. And for what it is showing is only the operators that we used, right? It's not the full repo, you can see. This is very, very powerful in my eyes. Let's do the same thing with Airflow 3. It shows me the SDK. It shows me the provider, standards, and whatnot. One very nice thing, check this thing out. He tells me operators on the outside are deprecated. So consider doing something else. Fast API, whatnot. This is also nice. He tells me the two different ways the operators work from 293 to 3. Last thing I want to show you is the task execution flow. So based on these traces that we have sent, we found out how the task execution flow works. So he tells us he will import the operator, then the scheduler will pick up the task, the executor receives it, the worker executes the task. How is he able to do this thing is we have given him the correlation between the logs from the core Airflow components and the traces that we generated. So in one go, without seeing much of the inner workings of the code, if you were having this set up in your own organization by enabling few of these sources, any new joiner can quickly see what kind of workloads their company is running. Same thing happens with the Airflow 3. Enough of this, I think. This will be there. You guys can check it out later on. Okay. we went so far, so further. How can we use all of this knowledge? I think maybe for debugging gives me very good idea. We can debug things, in my opinion, after all of this information much better than we could do before. We could easily identify the failing modules as well. We could see the exact call stack as well. Maybe it can help us optimize few bad areas of performance as well. I think so. But what is most interesting for me is this learning path where we went together for the last 30 minutes or so. We now understand the internals of Airflow on our demand, meaning Airflow is there for us, we use it, and we get taught by it automatically. We can see the design patterns, and actually we can now know which modules we would like to extend, even by the accuracy of line by line. And I think it can also help us with some of the production workloads, optimization as well, maybe in the side of alerting as well, if we were going the path of LLMs. And lastly, I just want to thank one more time the community, which has done the great work for Airflow 3 not only, but also all of these unsung heroes of all of these operators that happen for us every day. That's very cool to see. So, as I said, there is this repo where I have put in the code. And this does not have all the code yet, so I will upload the remaining pieces later on, but it does have the basics, and you can actually find the presentation there as well. With that, I want to thank all of you for the time that you have given and the attention you have paid to me. Thank you very much.